Pre-Calc Honors. So today we are going to do day 2 of section 5.1. We're still talking about trigonometric identities. And if you take a look at your notes from day 1, we had a lot of identities listed. So if you take a look at today, we're going to talk about cofunction and odd-even identities to start. And notice we have quite a few identities here. Now, I don't think I would go ahead and try and memorize those, even though some of you might want to do that. I personally wouldn't. I think I would just graph them, and I will show you what I mean in just a second. So, for example, if you take a look at the first example, it says cosine theta equals 0.34. Find the sine of theta minus pi over 2. Well, one thing is you could take a look at the red function, that's the cosine function, and the blue function, that's the sine of theta minus pi over 2. And notice here, so these are, oops. So if you look at your red function, because again, they're saying the cosine of theta is 0.34. Notice that the values of theta that satisfy this equation, right here, okay, those same values of theta will satisfy the equation sine of theta minus pi over 2 equals negative 0.34, right here, if you're looking at the blue function. So that's why we know that the sine of theta minus pi over 2 is negative 0.34. But I think a better way to do this might be using trig identities. So let's solve this using trig identities. So for example, let's start at the beginning. Pretend we don't know the answer right now. They're saying sine of theta minus pi over 2. That's what we're looking for. So if you think about sine of theta minus pi over 2, so again, it's graphed over here. Notice it's sine of theta moved right pi over 2, so it is this blue function. I'll make it furry right here. So if you look at that function, do you realize that that is really just the cosine function reflected over the x-axis? Okay, so that means then that the sine of the quantity theta minus pi over 2 is really just the opposite of the cosine. Right? So if the cosine is 0.34, then we would say that the sine of theta minus pi over 2 is really just negative 0.34. And so that is probably a better way to get the answer, to go ahead and use trig identities. Let's go ahead and do another example. Let's say I told you that tangent of pi over 2 minus theta is negative 1.32. So again, maybe we might want to start by thinking about what does that graph look like. So if we have the tangent of pi over 2 minus theta, that's the tangent of the opposite of theta minus pi over 2. So that says take your gorgeous tangent. So here's my tangent curve. There we go, looks something like this. It says take that tangent, reflect it over the y-axis. So tangent of the opposite of theta reflected over the y-axis. I'll make it furry, looks something like this. And then another transformation says move it right pi over 2. So here's the tangent of the opposite of theta minus pi over 2. There we go. And notice it really looks like a cotangent graph. So that means that the tangent of pi over 2 minus theta is really just the cotangent of theta. So now if they say find the cotangent of theta, well, the cotangent of theta then must also be negative 1.32. And again, looking at the graph there in Desmos, you can see that the tangent of the quantity pi over 2 minus theta is really just the cotangent of theta. Okay, let's do another example. Let's go ahead and do number 3. You might want to pause the video and try this one on your own. Okay, when you come back, let's take a look. So first of all, they're telling us something about the sine of the opposite of theta. Well, let's think about that. If the sine of theta looks like the blue function here, right? If you reflect it over the y-axis, notice the sine of the opposite of theta is equal to the opposite of the sine of theta. So unique to a sine theta, not to every graph, not to every trig function, but if you reflect the sine over the y-axis, it will be the same as the graph of the sine of theta reflected over the x-axis. So that's a trig identity right there. So now they're saying, let's take a look at what is the cosine of pi over 2 minus theta. Well, that's the cosine of the opposite of theta minus pi over 2. So if you take a cosine curve, there's a cosine theta, and you reflect it over the y-axis, it will look the same as your cosine curve. And then if you move it right pi over 2, notice, let's see, this would be at negative pi over 2. So you have a graph that looks like a sine curve. So again, on the previous page, there were a lot of trig identities listed. I don't think I would memorize them. I think as I need them, I would just graph them. So now we know that the cosine of the quantity pi over 2 minus theta is really just the sine of theta. And we know that the sine of the opposite of theta is really just negative sine of theta. So that's how we know that the cosine of pi over 2 minus theta is the opposite of 0.25. Okay, so let's take a look at the next part where it says use identities to simplify an expression. Okay, so we would like to simplify the expression for number 4. So why don't you pause the video and see if you could graph the cotangent of negative x and the cotangent of pi over 2 minus x. And instead of just flipping back to the first page to get the identity, why don't you see if you could just, sketch the graph and figure out what it is. Okay, so now that you're back, so notice that the cotangent of x looks like this, right? And so if I want the cotangent of the opposite of x, that is a cotangent reflected over the y-axis. So there we go. Right? And now for this this other term that we have, it says the cotangent of pi over 2 minus x. Well, that's the cotangent of the opposite of x minus pi over 2. So it says take your gorgeous cotangent, reflect it over the y-axis, and then move it right pi over 2. So do you see how if we reflect the cotangent of the opposite of x, cotangent of x, and then move it right pi over 2, we actually have a tangent curve. So we know that the cotangent of the opposite of x, if you look at this picture right here, if you take the cotangent and reflect it over the y-axis, you'll get the same result, and again, not for every trig function, but for this cotangent graph, as if you would have reflected it over the x-axis. So the cotangent of negative x is actually just the opposite of the cotangent of x, and the cotangent of the quantity pi over 2 minus x is equivalent to the tangent of x, so you end up with a negative 1. Okay, so let's take a look at number 5. So we need to know, and I'm going to go ahead and erase this, we need to know what is the sine of pi over 2 minus x. So go ahead and pause the video. Don't turn the page and look at the identity. See if you could go ahead and graph this and figure out an equivalent expression for the sine of pi over 2 minus x. Okay, so did you take your sine curve, reflect it over the y-axis, and then move it right pi over 2? Okay, because if you did, hopefully you ended up with the cosine curve. So if the secant is 1 over cos, and the sine of the quantity pi over 2 minus x is the cosine of x, you can simplify this expression to 1. Okay, let's go ahead and do part 3 now. We're going to do some solving. And so when we solve trigonometric equations, it's really important what interval we're looking at. So we're going to start by thinking about an interval from 0 to 2 pi. So if I have the sine of x equals negative 1, and you're thinking about your unit circle, the sine is the y-coordinate. So for A, if I said I want to look between 0 and 2 pi, hopefully you would say, well, x is 3 pi over 2. So go ahead and pause the video and write down your answer. What would you put if I change the interval to be negative pi over 2 to positive pi over 2? Okay, so did you realize that you would have to describe your answer as x equals negative pi over 2 if I change the interval to negative pi over 2 to positive pi over 2? Now for part C. So I would like you to go ahead and find all solutions in radians. So I would like you to describe this answer, but then again, you could go around the circle. You could add 2 pi. We could think of it as a negative angle. We're going to say k is an integer. So you would say x is 3 pi over 2 plus 2 pi k, because again, k could be 0. Integers are positive, integers are negative, so you're adding 2 pi, you're subtracting 2 pi. Now notice that's not the only way to describe it. You could have also said negative pi over 2 plus 2 pi k. That would also work. So I would like to go ahead and do one more example. What would happen if you have, for number 7, cotangent squared? There are a couple ways you could think of this. You could take the square root of both sides of the equation, or you could have thought of this a different way. Some people like to factor. I think it helps to get 0 on one side of the equation, and then you could have factored this. And you get the same answer, that the cotangent of x is positive or negative root 3. So we have answers in all 4 quadrants. The cosine is root 3 over 2. The sine is 1/2, right? So you end up with reference angles of 30 degrees. So for part A, you could say pi over 6. You could say 5 pi over 6. 7 pi over 6, and 11 pi over 6. Now for part B, if I want all solutions in radians, there are a lot of ways you could have done this. You could have said pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k, 7 pi over 6 plus 2 pi k, 11 pi over 6 plus 2 pi k. Or you could have been more concise. And again, k is an integer. You could have said, you just have to make sure that you have all of these angles and their coterminal angles. So you could have said plus or minus pi over 6 plus pi k. That would have worked, right? So there is not just one way to describe all of those angles. So that was part 1, and we'll go ahead and do 2 more examples in part 2 of the notes video. Great job, everybody.